Evaluate the derivative at the given value of x if, here's a function I give you for y equals negative 5 over x squared plus 3 over x to the 5th power, and I want you to find dy dx when x is equal to 1. So what you're going to do is find the derivative, okay, find y prime, and plug in x equals 1. So before I can just jump into the derivative part, I think I'm going to have to rewrite this ugly mess. Notice that x squared and x to the 5th power, those two are in the denominator, right? I'm going to move these up, okay? So look at how I rewrite these. I will write this as negative 5, x to the negative 2nd power. The next term will turn into 3 times x to the negative 5th power. And then take the derivative. Find y prime. Find dy dx using power rule. Multiply negative 5 times negative 2. That's going to give me positive 10. So I will have 10 times x to the, go down by 1, negative 3. Next, I multiply 3 times negative 5, which will give me negative 15. Negative 15. And you go down 1 from the original exponent. So the new exponent is negative 6. I will, they wanted me to find dy dx, so I'll call it dy dx, but that's what y prime is that we just found. Well, dy dx is, I'll write this back in a fraction format. 10 over x to the positive 3rd power minus 15 over x to the positive 6th power. When I send them back to the bottom of the fraction, these exponents turn into positive. Now, what was the answer? What did they want us to do? They wanted us to plug in just x equals 1 into this dy dx. So what's the final answer going to be? Let me do the work right here. 10 over 1 to the 3rd power minus 15 over 1 to the 6th power. Dividing by 1 doesn't really change anything. So we're just going to do 10 minus 15, and the answer, the final answer, comes out to be negative 5. So show me how you can rewrite these expressions using the exponent property first and apply the power rule to find dy dx. Last thing you're going to have to do is just plug in that given x value to get your final answer.